Okay, so today we're going to start Chapter 4, the factors and the products of polynomials. And we're going to start with Section 1. And Section 1 is working with polynomials. So some of this, if not most of this, or all of this, will be a review from Algebra 1. But you're going to need all these things in order to progress in the chapter and then apply this with other things. Okay. Oh, lovely. It always does this.
Why don't you just do that so it stops coming up?
I don't know how to keep it from coming up. Okay. A monomial. What's an example of a monomial, Maggie?
Huh? I'm sorry.
Wait, what's that say?
I feel
Monomial?
like x plus 1.
Oh, yeah.
A constant.
Monomial. I want an example of one. Not on the sheet, but just make up one.
5.
5, okay. What else, Courtney Hellman, that has a 5 in it? 5x, okay. What else, Claire, that has a 5x in it? 5x squared, okay. Courtney?
Y.
5x squared y. Okay. It's any constant, which is just a number, or a variable, or the product of a combination of constants and variables. That's a monomial. In this particular monomial, the number 35, which is the constant part of the monomial expression, is called the coefficient. Okay? The part that's not the constant, this is called the coefficient. Who knows what this is called? Anyone? It's called the variable expression. Okay? And in order to add or subtract monomials, you have to have like terms, or meaning exactly the same variable expressions. So, Jared, what is 4x, Jared, plus 3x squared? Who thinks it's 7x squared? Raise your hand.
I don't know.
Is that what you think, Michael Moody? You think it's 7x squared? Who else agrees? Who thinks it's 7x squared? What do you think it is, Austin?
You can't really simplify it because the x is...
Right. 4x plus 3x squared is 4x plus 3x squared. Because these aren't like variable expressions, if I have 7x squared minus 3x squared, what's that, Jared? 4x squared. I can, as long as I have like terms, like variable expressions, I can add or subtract the coefficients to simplify. But if I don't have like terms, I can't simplify. What is a binomial? Megan, give me an example of a binomial. Two monomials.
I just remember there's 2.
Give me an example of them. 3, 3x plus 2. Okay? Notice what I have. I have 2 monomials separated by addition or subtraction. We call these monomials terms. Okay? So every monomial that's separated by the addition or subtraction sign, and really what is subtraction? It's just addition of the opposite. So 3x minus 2 is really just 3x plus negative 2. We call these terms. If there are two terms, we call it a binomial. The Greek prefix bi means two. Bicycle, biplane, 2 layers. So when we say binomial, it's 2. Okay? What's that? Crystal, what's a trinomial? 3 terms. Give me another term. 4y. Okay? Now we have 3 terms. Now we have a trinomial. And all of these, whether it's a monomial, a binomial, a trinomial, or more than 3, 4 or more terms, they're all polynomials. The prefix poly means many, or more than multiple, okay? So any of these are all polynomials. All right. The degree, 4x to the 7th power plus x to the 6th power minus x to the 5th power plus 2x to the 4th power. Okay? Each of these monomials have a different degree. The degree just means the highest exponent in the monomial. So this particular monomial is a 7th degree.
Can't you just write 7?
I'm sorry?
Can you just write 7?
It's a 7th degree monomial. This is a 6th degree monomial, a 5th degree, and a 4th degree. What is Bethany? 4x. What degree is that polynomial? 1. The exponent's a 1, so it's a 1st degree polynomial. What about this, Maggie? 6. What degree polynomial is that? 0. And it's because you're multiplying this really by x to the 0 degree. What's anything to the 0 degree, to the 0 power? It's 1. So 6 is really 6 times 1, or 6 times x to the 0 power, which would just be 6 times 1, or 6. So we don't write all that. But it's a 0 degree polynomial. I don't know if they'll ask you that, but I'll mention it just in case. All right. Now, when they're doing degrees of... Now, they want to know what are the degrees of a polynomial. So, if I have 5...
But isn't anything times 0, 0?
It wasn't times 0, it was to the 0 degree.
But I don't understand that.
Any number to the 0 degree equals 1. Doesn't matter what this number is. 4 to the 0 degree, you just got to memorize that.
Why wouldn't it be like 5 to like 1?
That'd be 5.
Right, 5 to the 1st degree is 5. Because 5 to the 1st degree means 5.
Right. So.
But this is 1.
No.
It's not 5.
That's not.
All you have to memorize is that anything to the 0 degree is 1. As long as you remember that, you'll be okay. All right. 5x cubed minus 2x squared plus x minus 4. Sam, what is the degree of this polynomial?
3.
Third, right. They want the highest degree of all the monomials, which is 3. So this is a 3rd degree. So if they ask you what degree is the polynomial, that's a 3rd degree. That's what they mean when they ask you for the degree of the polynomial. What's the highest exponent in all of the polynomials? Now, when you write these things, you need to write them in order of decreasing degree of the monomials. So this is the proper way to write these. So if they gave you something like this, 7 plus 2x cubed minus x plus 3x squared, how do we write that in the right order, Michael Moody?
2x cubed plus 3x squared minus x plus x.
Right. Okay? So you have to write them in that way. All right, so let's go on to these worksheets, and let's see what we can get, where we can go. We'll start with you, Austin Farrell. Number 1, it asks you, it says simply arrange the terms in order of decreasing degree of x, then write the degree of the polynomial. So number 1.
Negative 5 cubed plus 5x squared
figure, is our homework gonna be like this?
I didn't go through the book. I just went by Mrs. Novicus' assignment that she puts on her sheet. So I didn't go through it, so I can't. But I would imagine this goes with the book. So I'm sorry, Austin. You said 5x squared.
Plus 3x squared plus 1 minus 2.
And then you got to simplify this. So how are you going to simplify this?
Negative 5x cubed plus 8x squared minus 1.
Good. And what's the degree of the polynomial?
3.
So third degree. Does everybody get that?
Yeah.
Okay. All right.
Wait. You have to simplify it? That was what
Well,
it
just at the key.
It just said at this one to arrange them, but you can't really arrange them unless they're simplified because which would come first? They're both second degree.
Oh, right.
So in order to arrange them, you just combine them, which you'll need anyway. Let's do one more of these. KJ. Let's do this one. 3 minus x squared plus 3x squared minus 5 plus 2x squared plus 3x cubed. So let's arrange that and then give me the degree. You want the highest exponents first. So look for the highest exponent first.
Yeah. That's good. Oh.
Guys, let her do it. She doesn't need help. Which one of these has the highest exponent? I'm sorry?
15.
The 3.
Yeah.
We call that cubed. But 3x cubed. Okay, now what?
And
Well, hang on a minute. You've got 3 of them. You got minus 1, plus 3, and plus 2. So what's that going to give you? 4 of your x squareds. Then what? Minus 5 plus 3 minus 2. And what's your degree? What's the degree of the polynomial? I just want the highest number, okay? Third degree. Okay, let's move on to the back page of this on 54. I just want you to add some of these, which isn't too bad. And then they want you to subtract. So let's do number 7, the first one they have here. 2x plus 3. And then they want you to first add. Okay? How am I going to do that, Maggie?
do you combine the plus?
You sure do.
So you add 2x and 5x,
Which is?
the 7x. And then you add 3 and 9, which would be -3.
7x minus 3. And then they want you to subtract them. How am I going to do this, Courtney Thorne?
Combine like terms.
Okay.
So it would be 3x.
I'm sorry?
It would be 3x.
Be negative 3x, right? You have positive 2
Oh,
minus
sorry.
5.
Yeah. And then would that become positive?
It sure would.
So positive
Plus 9. Does everybody see that? Your negative, did everyone see it here? That you're distributing that negative throughout the whole quantity when you're subtracting. Okay?
Would
Yeah.
it be okay if you put them on top of each other and then subtract it like that?
Yeah, no, that'd be fine if that's easier. Some of you might, she's saying, is it easier to do the 2x plus 3 minus 5x minus 6? Just remember when you minus it, you have to do both sides. So then you have minus 3x plus 9. For some of you, that may be easier. I think in Algebra 1, that's what you learned, right? To stack them vertically, and it'd be easier adding them and subtracting them, maybe. Whatever's easiest. I tend to think that might be easier. Whatever you like. All right, let me find another one of these here. Let's do number 14. That one looks tough.
What looks tough?
Well, number 14. All right, x cubed plus 2x squared minus 3x plus 2 plus 3x cubed minus 2x squared plus 4x minus 5. Megan. Cubed. Okay. Minus.
So there's a 4x and a negative 3.
So it'd be plus 1x, right? You have 4 positives and 3 negatives. So it'd just be plus x, right?
Yeah.
Okay.
Minus 3.
Minus 3. What degree is that polynomial?
3rd.
3rd degree. Okay. Let's subtract these things now. X cubed plus 2x squared minus 3x plus 2 minus 3x cubed minus 2x squared plus 4x minus 5. Courtney Hellman.
What number is this?
14 on the sheets.
Why did you put the 3x squared and 2x in parentheses?
Because you're subtracting that whole polynomial. First we add the polynomials, then we subtract it. I didn't need to put parentheses up here because when you're adding, it's all commutative. Adding is all commutative, so it doesn't really matter. Subtraction's not.
Oh,
Okay? So it's important. Go ahead, I'm sorry. Positive or negative? Minus 2x. What did you say, cubed? Okay. I can't hear you. You gotta. Well, we gotta do the x squareds first. What do you have here? Plus 2x squared plus 2x squared is plus 4x squared. Guys, remember that when you're subtracting this whole quantity, you're adding the opposites. Okay? Now you can go ahead with the x's. You got minus 3x and minus 4x. I'm sorry, I can't hear you. What's negative 3 minus 4? Negative 7. Minus 7x. Okay? And then you have 2 plus 5. What degree is that polynomial? 3rd. Okay. That's what they're asking you to do on this section. Let's see. And then they use some nice distributive properties, so let's do that. We'll go down to number 15. 4, 2a squared plus 3a minus 2 plus 2a squared minus 6. Notice here that you have to use the distributive property in order to simplify this. 4 times 2 is 8a squared plus 12a minus 8 plus 2a squared minus 8. Okay? And then you can simply combine. 8 plus 2 is 10a squared and plus 12a minus 16. That's what they're doing here for the the second section, 15 through 18. They're using the distributive property to simplify these. I'm skipping the mixed review. You all like those slopes, I know, but where am I? So, turn on the back, or the next page. Some of you it's the back page, I'm sorry. Some of you it's...
What? We don't have a page.
Wait, why is it minus 16?
What's that?
Why is it minus 16?
I'm combining.
Minus 8, minus 8. 8 minus 8 is 16.
Is it 2 times 6 12?
Oh yeah, I looked at 4. Nobody else caught that?
I honestly could care less, so.
Yes. It was, no, I'm sorry.
No,
Minus
20.
12.
20.
Okay. All right. Let's go over the 3 rules for exponents that are really important, and you got to know it out of this section, okay? The first one.
Okay.
Oh no, they use those in the next one. Okay, that's fine. Let's do some more of these.
Can we start off?
No, not yet. We still got 15 minutes. Let's see. 5. We're doing number 18, guys. 5x squared minus x minus 2 minus 3, 3x squared minus 2x minus 6. Okay. What are we going to do here? What are we going to do here, Claire? Distribute. So what am I going to get?
5x minus
5x squared.
minus 5x minus 10. Minus 9x squared plus 6x plus 8.
Good job.
And how am I going to combine that?
Combine 5x squared and negative 9x squared to negative x, 4x squared. And then it'll be just x plus x, and then 8 plus 8.
All right. Let me just double check the ones in the book and make sure there's not anything else that you haven't. Find the value. All right, yeah, let's do that. I'm going to go to the book, and I'm going to do number 26. And on page 170, I'm going to do 26, because this one looks like that might stump some of you. Ax cubed minus 3x squared plus 2bx minus 2 minus 2x cubed minus cx squared minus 5x minus 4d. And then all of that, it said, was equal to x squared plus x minus 6. And then what it does is it says, find the values of a, b, and c that make the equation true. Okay. What's that? Are you in the book?
What was the question?
You gotta open up your book. It's on page 170.
I know, but what was the question? What do you gotta find?
Find the values for a, b, and c that makes the equation true. Okay? Okay, so how are we gonna start this? Bethany. Well, you have this, then you're subtracting this. So what do you do when you're subtracting that? Let's start with that. What do you do when you subtract a polynomial? Who can help her? What am I going to do over here when I subtract this polynomial?
Distribute -1.
Right, I'm going to distribute the negative and change all my signs. So let's say, and I'm going to have to write a little smaller to get this all in here. So hopefully you can all read this. Okay? So, okay. Now what can I do? Well, let's look at what our like terms are. So let's look at our variable expressions. Remember that your A, B, and C are going to be numbers. We're trying to find what the values of A, B, and C are. So A, B, and C are going to be numbers. These are our variable expressions. Sorry, that last one should be circled. Okay. Just look at the all right, those are your variable expressions. So we can combine our variable expressions, we can combine our like terms. So we have two sets of x squareds. What are we left with here if we combine these? Well, you have -2 plus a, right? Or just a minus 2 x cubed. Do you see that? If you don't, speak now, or forever hold your peace. All right. Now I have my x squareds next. I have c minus 3 x squared. And then I have, for my x's, 5 plus 2b. And, sorry, these were all adding these. And then our constants, we have 2b plus 4d. Okay? Now, all of this has to equal this. This is what it said that it equaled up here. Okay? So, notice here that we have no x cubed term. We have none. So, in order for these to be equal, this x cubed has to be 0. Okay? So, what value of a will make this 0, Jared? Okay. I'm sorry?
2.
Okay. And up here, we have no x squared. So what is c?
4.
I'm sorry?
4.
No? It's 3, right? 3 makes it 0. Oh, no, there was I'm sorry. There's a 1 there.
4.
So this is supposed to be 1. C minus 3 equals 1. So, yes, 4. I'm sorry. Good job. All right. Then our x variable needs to be 1. So 5 plus 2b equals 1. What is b? 2b equals -4. b equals -2. And then last but not least, we know b is -2. So 2 times -2 is -4 plus 4d equals -6. Add 4 to each side. And what is d, Jared?
And 2 and 4.
Which is? Those ones are a little trickier, but they're on your homework, so just so you're aware of it. And, okay. All right, you can have the last 10 minutes to start your homework. I'll come around to ask questions, but please don't start talking. Actually use the time for your homework, because some of these will be tricky for you.